Now, what you see right now on a picture looks like some very busy activity happening. Lot of onlookers here, lot of people are watching. Something is happening, and it has something to do with technology. Because if you read it little carefully, I could read IBM. Anyone? What is happening here? Subhash is saying 256 MB pen drive, hard disk. What else? What else? Yeah, Logeshwaran hard drive. Exactly. Yeah, loading IBM storage on a ship. Yeah, it's a trailer. Yeah, so it looks like on a trailer, first hard disk. Not first, but somewhere nearby, because it is like what IBM used to call it. It is a 5 MB portable hard drive. 5 MB. Is it portable? Yes. If you have 10 men, one lorry, yes, you can port it. Then 5 MB, you can imagine how much size it is. And let me give you a little more example. Right. See this one. This one is 1 terabyte Micron or memory card, and we probably have more sizes coming up soon. So you can imagine that what road the storage has traveled from that big bulky storage up to a smaller, just a bite-sized storage which we have and huge capacity. Now you may be thinking why I am talking about this, because this is how storage evolved, and this played a crucial role in how our databases evolved too. So in early days when computing started, everything was so costly that anything you were doing, the main focus was, hey, what can I do so that I would be able to save some storage? I wouldn't be able to, I don't want to duplicate my data. I want to ensure that I am keeping the same stuff in a very less storage space. So that was the main important aspect of whoever was developing anything. Same time, databases was coming up. Databases is not very old technology, just 1970 somewhere in IBM somebody thought, let me start by creating a database where I would have a structured data stored in a basic format, and that started with what we call SQL databases. So SQL came and that was optimized for storage, because that time we need to have everything bite size, everything compressed so that we do not eat up a lot of space. But then came Web 2.0. These new companies, Amazon, Facebook, where we have lots and lots of user, millions of user accessing the application. That was not where these databases could work. It was not designed for it. It was designed to be run into enterprise environment, maybe 10,000, 50,000 users using it. But once we started using web application, which were millions of users like social media, your presentation sharing, maybe your YouTube type services, there were millions of users, and these databases were not able to cope up, and that's why they came up with new SQL, NoSQL databases. These were optimized for performance. So focus is different. SQL, they were optimized for storage, efficiently storing the data, whereas NoSQL was designed in a way that we want to ensure that we are able to give best performance to anyone regardless of the number of user using it, 10, 15, 100, 200, it doesn't matter. We want to give the same performance. And obviously, it means that we have to change the way we were storing data. So in SQL, everything was stored into rows and columns. This is a typical way of storing data. You would have structure, you would have table, you would have primary key and connection, and that's how you would be storing your data. But when NoSQL came, NoSQL said, hey, we want to store data in some different format, which is optimized for a specific use cases. And that's why we call it that NoSQL databases are purpose-built databases. They were designed to serve specific purpose, maybe graph, maybe void column, maybe document, maybe key value pair. So that all happened when NoSQL databases started showing up, and they have different way of storing data. Like here I am mentioning some of them: key value, which is a way of representing the same stuff but in key value format. It could be a document format, what you see here, JSON, that is what a document DB Amazon supports, or MongoDB type of things. Those are document databases. Then there are wide column databases. When you do a lot of analytics, that time wide column databases can be very easy to manage. And then there are graph databases when we are talking about social media application, that we have applications like Facebook or Instagram, where you have likes, where you can connect to someone, where you can use LinkedIn to connect to someone. Those are all relationship which is being maintained, and that is called graph databases. So there is a different category which we call NoSQL. Now NoSQL doesn't mean I can't write a SQL statement. It doesn't mean that. Now, sometimes people think that NoSQL means, hey, there is no way I could go ahead and utilize a SQL command. You could, but there would be an interpretation required between what you write and what your system understand. But NoSQL doesn't mean not accepting SQL statement. It only means that they are having different methods of storing your data. So we'll talk about that. Okay, good. Not only SQL. Yeah, that is a good one. That is a good one, Padmaja. Schema. So SQL databases, when designed, they were having a fixed schema. If you remember, like I remember in my early college days, we used to have things like, hey, we need to create an employee table. So there would be employee ID, employee name, and that schema we had to design. Once a schema is designed, that is fixed. You could not change it. It was not frequently changeable schema. You have to be very thorough with what you want to keep inside and what structure you want to put around. That's why they are called fixed schema databases. But when NoSQL came in, that said, hey, why not have dynamic schema? Because our requirement can change, and just changing a requirement should not mean that I have to redesign the whole database layer. And that's why dynamic type of ways come in, and that's called my dynamic schema, which we are going to talk about in some minutes. So fixed and dynamic schema, that is the difference. Another difference comes in a query format. What happens in SQL, that you write a SQL query and the database has a understanding mechanism. It would interpret your query. It would identify that what is the best way to go to data and get your data and deliver it to you. So the engine of SQL is understanding the way you write query. You write query, it would do optimization, it would do way of filtering it down, it would do the narrowing of the data and deliver it back to you. So they were using SQL statement, whereas in NoSQL, we mostly focus on collection of document. We have to be very thorough with what we are going to ask or what we are looking from these databases. So if you see this here, I'm trying to select star from music, where artist is Elvis. Similar stuff, but here my information is little more elaborative. I'm saying, hey, I have a table called music. Condition is artist, and artist value is Elvis. Please give me that, and it will return all the songs by an artist called Elvis. So remains the concepts remain the same, but the way we query is little different. In SQL databases, you rely a lot on the SQL engine itself to interpret your query and optimally run it. Whereas in NoSQL, you need to design your indexes in such a way that your optimal query is returned much faster, and you do not eat up a lot of time on that. So that's how these things are working. Good. So that is how you would query SQL and NoSQL databases. Another advantage came is about scaling. If you see here, the only way to give better performance to SQL was to build a bigger box. I'm running a 2 CPU, 14 GB, 16 GB RAM box. I need better performance. Let me go to a 8 CPU and 32 GB RAM box and keep on adding more capacity. So it was a single box. And obviously, there is a limit that how much physical capacity you could put into one single box, and chances of that box failing would have devastating impact because everyone would be affected because that box has failed. So this is what we call vertical scaling. We were trying to add capacity in the same box itself, just getting a bigger box, whereas horizontal scaling says, hey, let's create nodes in such a manner that they work in a coordinated manner, and if we need, we could add more node rather than adding more capacity to one single node. So that's what we mean by horizontal scaling. And most of the time, your database vendor would provide this mechanism in such a easier fashion. You just add a node, automatically data replication would happen. You would be able to get your load spread out automatically, and maybe sometimes remove it also if that system provides you that kind of facility. So that's what is horizontal and vertical scaling, right? Hopefully everyone has these basic idea, and now comes another difference between them. Yes, that is called transaction. Now you may be thinking, what is a transaction? Not isn't everything a transaction? Yes, it is. But think about, let's say, a bank transaction. What I'm looking for, let's say I'm looking to transfer money from account A to account B, right? Financial transaction. So money should get deducted from my account first, then it should go into another person's account, and from there I should be able to get my money accessed. That's how things would work. So this is a whole transaction, which means you can't say, hey, I sent you $100 but you received only 50, because the transaction was not fully completed, it was partially completed. It won't work. So what we need to ensure that whatever we do is considered as a durable transaction. Once a transaction is happening, it won't be affecting other transaction. So we need to create lot of isolation when we are utilizing these databases. So simple example in this particular case would be, whenever I am trying to access a database, I would be requiring what we call here is called acid and base compliances. Now it is just a way of naming. Acid is basically, we say, atomicity. Consistency, isolation, and durability means whatever you are doing is a durable solution. Once you write data, it won't be lost. Transaction do not affect each other, right? So if you are having one account where money is coming in and money is going out, they would be treated in an isolated manner. They won't affect each other. Data would be consistent, and you would have transactions will be all or nothing. If I'm transferring money, either I would be successful or I won't be successful. It won't say, hey, you were able to transfer only 50%, nothing beyond it. So no, that won't work. So that's what we mean by acid compliance. On the other hand, your NoSQL databases work little differently. The importance in NoSQL database was on their availability, that we want to make our data available much faster. Even if it is not consistent, our system will be designed in such a manner that it won't be affected because of that consistency, and we are okay to have sometimes stale data. Our main importance is to make data available as much faster as we could. So that's what the difference between SQL and NoSQL.